Hey people, hello everyone. Thank you so much for joining. And in this session, we are going to learn about ordinal logistic regression. So for ordinal logistic regression, your y variable should be ordinal in nature. Example, maybe you will say low, medium, or maybe high, like as this is the ordinal data. Or data may be like as good, better, best, or maybe excellent. Or maybe you can have a data like our education system, maybe high school, then you will go for some college, then you will do the graduation, and you will go for the post-graduation like this. So these all the data are ordinal in nature. And your X variable is your numeric. Maybe you will say like as in marks, maybe the age, or maybe any other factor like as days attended, and many more things can be. Your X variable should be numeric. So we have the Y variable. If I say this is your Y variable, and you will have one X variable which will always increase. So suppose if I say that what are the marks in your college, so marks are increasing. And based on the number of marks you have achieved, and I am trying to find out that you have done the high school or you are attended or you have attended some college or you have attended graduation completed or you have completed your post graduation. I am trying to find out the probabilities. So how the chances will change? Suppose, let's say I'll try initially there is a positive correlation. So you are starting from here, and this is your on the x-axis is your years of education or maybe the marks. And if the marks are increasing, probably you have completed high school here. The more is the marks, probably there is a possibility that you have attended some college. Maybe you have got little more marks, you have completed graduation. Maybe you have attended a little more marks you have achieved, then you have completed post-graduation. So what do we see in this case? As on the x-axis, your marks are increasing, the chances of you have attended high school compared to some college, compared to graduation, compared to post-graduation. So as your marks are increasing here, the degree level is also increasing, which means there is a direct correlation. If you have got the highest marks, that means there is a higher chance what level of education you have achieved. Maybe it's a competitive exam where all the people are attending the competition, basic qualification high school, and based on the marks that you have achieved in the competitive exam, I wanted to figure out that what are the probabilities in case you have appeared for this competitive exam and your marks are at X value. Suppose, let's say your marks are here. So if you have achieved this much of mark, maybe 80 out of 100, and this line is crossing this value here, and if I connect with this, so there is a higher probability that you are a graduate person. Similar way, if the marks goes more here, like as, then there is a higher chance that you are a postgraduate. If your marks was low, suppose at this place only, so then there is a chance that you have a high school degree. Or if the marks are maybe your marks are here, and then there is a chance that you have attended some college. So based on the marks, If there is a positive correlation in the data, I wanted to find out with the help of ordinal logistic regression that what level of school education or college education you have done. Now let's take an example in the Minitab. So I have the similar kind of data. I have education level, and this education level, I have a predictor variable, and I can choose the predictor variable in the Minitab any one. Maybe I have your, let's say, writing score. So how was your writing? How much score you have done or you have achieved in the writing? Based on that, I wanted to find out that what are the probabilities that you have a bachelor degree, some college, master degree, or maybe high school like this. This thing we can identify with the help of ordinal logistic regression. So first thing, we understood the data. Let's have one more categorical variable I will have. And let's say I wanted to figure it out, your education level, when these marks you have achieved with test preparation or without test preparation. Suppose. So test preparation without means none, and test preparation yes means completed. So first thing, we'll go to the stat option, regression, and we'll go to the ordinal logistic regression here. Response variable is your education level. In model, I wanted to find out with the help of writing score. That's all. Categorical variable I will tell you later. Nothing to do, just click on OK. And such output will come. So here is the bachelor, high school, master, or some college. Before I look for anything else, either the odds ratio, p-value, or the slope, or the deviance p-value, the first thing I need to check, is this the correct order, the way we wanted to define the ordinal logistic regression? Answer is no. Because it's not like that in the ascending or descending order, bachelor, high school, master, or some college. This is not the right order. So first thing, I have to correct the order in my data. For that, I'll go to my data table. Anywhere in the education level, I'll just right click. We'll go to the column properties. And here I will define the value order. I will go for the user defined order. And now I'll do the correction. So I think first thing will come high school, then some college. So high school, some college, then bachelor, and then master. I think this is the right order now. High school, some college, bachelor, and master. I will click on OK. Now my order has changed. I will go back to the stat, regression, ordinal logistic regression. Again, same education level is y variable, x variable is your writing score, and click on OK. And when I rerun this equation, now I got the high school, some college, bachelor, and master. And this is the correct order. You see, p-value for all of the input variable, all of these four, is less than 0.05, which means significant impact. Odds ratio is 0.97, which is less than 1, which means as my input variable, there is a what kind of relationship? Negative relationship here. As your marks are increasing, the probabilities are decreasing, which means probability of a high school compared to some college is less. Probability of some college compared to bachelor are low. Probability of bachelor to master are low. Or we can see in this way, as your marks are increasing, probably here you have the high school, then you have the some college, you have bachelor, or you have master. So this line is going in this direction positively, you can say, because my order is like this. So in this case, I'll say this is a reverse order because of this value is low. If I define my order, master, bachelor, some college, high school, then this odds ratio should have been come around 1.03. So what do we understand with the odds ratio? If odds ratio is 1, that means there is no relationship between x and y. If odds ratio is greater than 1, then as the value of x is increasing, the value of y is increasing or chances or the probabilities are increasing. And if odds ratio is less than 1, which means on the decimal side less than 1. So as your input variable is increasing, which is your marks, then the probabilities are decreasing. Like exactly we have seen in this case, our odds ratio is 0.97. So as I go further, my marks are increasing. The chances or the probability you have high school compared to some college are low, or you have a some college degree compared to bachelor are low, or you have a bachelor degree compared to master are less. We will look for the p-value significant. We will look for the all slope equal to 0, which means these p-value or these degrees have a significant difference from each other or no. So answer is yes. At the same time, I will look for the goodness of fit test, and especially I will look for the deviance p-value. And deviance p-value should be greater than 0.05 to say that data fits very well. So I have evidence that all the degree level here are not same. These degrees are different based on the marks what we have achieved in writing score, which is significantly different. And this data fits very well to this. This is how we'll read it. Now suppose I want to add categorical variable in our data. That does it make any difference with the test preparation completed or not completed? So I'll edit this equation, and here I am adding the categorical variable test preparation. Now I click on OK and reread the equation. So factor I have to add here, which I missed. Now education level is in the order. These values, p-value. Writing score, now you will see odds ratio has come as an 0.96, and you will see significant impact of the none when you are not doing the test preparation. Then the probabilities are decreasing much faster compared to only the writing score. 0.71 odds ratio, which means it's much away from the, it's a far away from the 1, much lower than the 1. So which means probabilities are decreasing much faster. All slope equal to 0, data fits very well here. Equation is significant, and deviance p-value greater than 0.05, data fits very well. Further, you want to do the analysis. So I can do generate the probabilities of that. I'll go to the storage. In storage, I'll go here, enter the number of events. So what events I have? High school, some college, bachelor and master, total 4 events I have. So write as a 4. Click on the event probabilities and click on OK. Now, the chances of high school, bachelor, master, or some college are here in a specific order. So you see in these tables, first one is the high school. So high school, these are the probability of high school when you did not prepare for the test and writing score is 74. Then chances that you have a high school degree are 29 out of 100. You have some college degree, as the second order is some college in this table, which is around 48%. You have bachelor degree, the chances are around 14%. And you have a master degree, the chances are around 7%. This is the way we will define this. Now you want to see the relationship of these y variable with your input variable test preparation along with the writing score graphically. So we can go to the graph, scatter plot, go to the with connect and the group, because the test preparation group we have in our data. Y variable is your high school, input variable writing score, then some college, then again with writing score, then bachelor degree, then writing score, and again by variable master degree, and input variable is writing score with a categorical variable of test preparation, none or completed. Go to the multiple graph, and maybe you can select on the separate graph. Perfect. That's all you need to select. Click on OK. And now you will see the graphical relationship here. So first graph is scatter plot for high school versus writing score. As the writing score are increasing, the chances you have high school are decreasing as per the data. And it decreases faster when you did not prepare for the test preparation compared to when you completed the test preparation. Because not completed or none has the sharp line compared to the completed. If you go for the some college versus writing score, as the writing score is increasing, there is a chances, higher chances that you have the some college up to the score of 80. Then it start decreasing. Similar way for the completed and non-completed. Completed is the blue line, not completed is the brown line. We can see further for the bachelor and the writing score. So bachelor degree, as the writing score is increasing, the probabilities that you have a bachelor degree is also increasing. Maximum probability is up to 25%, starting from somewhere around 5 or 6%. Now, master degree, even this increases very sharp. Comparatively to any other, this is the sharp increase. So writing scores are increasing, their master degree chances are also increasing. And this is the way we read, interpret, and run the ordinal logistic regression. Thank you so much, people. And in the next session, I will explain the nominal logistic regression.